We are solving question number 10 of GATE 2013 chemical engineering paper, and this is related to the subject of fluid mechanics. The question states, the apparent viscosity of a fluid is given by this equation where dV by dy is the velocity gradient. The fluid is dash. So in this given question, we have been provided an apparent velocity, and we have been asked to find that what kind of fluid does it, which kind of fluid is it. So over here, we have been given apparent viscosity. That is mu is equal to 0.007 dV dy raised to 0.3. Now we have the correlation between the shear stress and the strain rate given by this equation, also known as power law equation, or let's say power law model. That is, shear stress will be equal to mu naught upon dvx upon dvy raised to n minus 1 dvx upon dy, where this term is apparent viscosity, which we are calling it as mu. So if we compare both of this equation, mu naught dvx by dy raised to n minus 1 with this equation, we can see that the value of n minus 1 is equal to 0.3. From that, we will be getting the value of n equal to 1.1 plus 0.3, that is 1.3. Now, in the given question, we have been given first Bingham plastic. Okay, so the shear stress and the strain rate correlation for the Bingham plastic is given by this equation, that is tau is equal to tau naught plus mu dvx plus dvy, whereas in our case we are not having this form, so this Bingham plastic is not a correct answer. Then this thixotropic fluid is time dependent, so in our case also we haven't been mentioned that it is the viscosity is time dependent, so this thing is also incorrect, thixotropic. Now we are left with two options, option B and option C. Now for this dilatant fluid, the value of n should be greater than 1, and for the pseudoplastic fluid, the value of n should be less than 1. Now in our case, we are getting the value of n as 1.3, that is greater than 1. That implies the fluid that we are dealing with is dilatant fluid. So since n is greater than 1.3, we will select the final answer as dilatant fluid.